Your glutes are not a vanity muscle, they are the engine of your survival after 50. The body does not announce its losses loudly. It diminishes in increments so gradual, so woven into the ordinary rhythm of daily life, that most people attribute the changes to everything except the one process quietly unfolding beneath the surface. A little more effort climbing the stairs. A reluctance to walk for long stretches without discomfort. A heaviness in the hips that was not there a decade ago. These are not random inconveniences. They are the early language of sarcopenia, the progressive, age-related loss of skeletal muscle mass and the functional strength that accompanies it, and they deserve to be read with the same attention we give to any important signal the body chooses to send. Sarcopenia does not wait for old age to begin its work. From approximately the fourth decade of life onward, the human body begins losing between 3 and 5% of its muscle mass per decade, a rate that accelerates considerably after the age of 60. What makes this process particularly consequential is not merely the loss of size, but the loss of the quality and responsiveness of muscle tissue. The way it contracts, the speed with which it generates force, the precision with which the nervous system can recruit its fibers on demand. These are the properties that allow a person to catch themselves when they stumble, to rise from a chair without using their arms, to carry groceries without bracing against discomfort. Within the broader architecture of the body, no muscle group bears the consequences of this decline more visibly, or more profoundly, than the gluteal complex. The gluteus maximus, the largest single muscle in the human body, functions as the primary engine of hip extension. Every act of pushing the body upright from a bent position, every step forward that requires the trailing leg to propel the body's mass through space, every moment of stabilizing the pelvis against the lateral forces of walking, these all depend on the gluteal system functioning with integrity. When that integrity is compromised, the surrounding structures begin to compensate. The lumbar spine takes on load it was not designed to sustain alone. The knee joints shift into mechanical patterns that accelerate cartilage wear. The hip flexors tighten in response to the imbalance, pulling the pelvis into an anterior tilt that compresses the lower vertebrae with every step taken. What sedentary life does to the glutes goes beyond simple disuse. Prolonged sitting places the gluteus maximus in a chronically shortened, unloaded position, and the nervous system, ever adaptive, begins to reduce the priority it assigns to recruiting those fibers. Exercise physiologists have a term for this pattern: gluteal amnesia. It is not a failure of the muscle's capacity. It is a failure of the brain's habitual pathway to the muscle, a communication line that has grown dim from neglect rather than damage. This distinction matters enormously because it carries within it a reason for genuine optimism. A pathway that has dimmed can be relit. A muscle that has been underused can be re-engaged. The biology of adaptation does not expire with the passing of a certain birthday. Understanding this, truly absorbing it rather than simply hearing it, changes the way a person approaches the years after 50. It shifts the conversation from decline to dialogue, from loss to the possibility of restoration. The gluteal complex, for all its vulnerability to the habits of modern life, remains one of the most trainable and most responsive muscular systems in the body at any age. The science of neuroplasticity and muscle physiology both point toward the same liberating conclusion. The relationship between the brain and the glute is not fixed, and the effort required to rebuild it, while requiring patience and consistency, does not require youth as its prerequisite. There is a moment, somewhere between the third and fourth repetition of a well-executed hip thrust, when something shifts. It is not dramatic. It is not painful. It is more like a recognition, a sudden, unmistakable sensation of a muscle waking to a demand that the body has not felt in years. That moment is not simply physical. It is neurological. It is the sound, so to speak, of a dormant motor pathway being reopened, of the brain rediscovering a line of communication that years of sitting and stillness had allowed to fall nearly silent. Understanding why that moment happens, and why it matters so profoundly for the body after 50, requires us to look not just at the muscle itself, but at the entire system through which the muscle is commanded to act. Motor units are the fundamental organizational structure of muscular contraction. Each motor unit consists of a single motor neuron, a nerve cell originating in the spinal cord, and the cluster of muscle fibers it controls. When the brain decides to produce movement, it sends an electrical signal down through the spinal cord and along the motor neuron, which then triggers every fiber within that unit to contract simultaneously. The strength and speed of a muscular contraction depend not only on the size and condition of individual fibers, but on how many motor units the nervous system recruits, how rapidly it recruits them, and how precisely it coordinates their firing. This is what exercise physiologists mean when they speak of neuromuscular efficiency, and it is exactly this efficiency that erodes most predictably with age and disuse. The hip thrust intervenes in this erosion at a level that few other lower body exercises can match. When the hips are driven upward into full extension against load, whether that load is bodyweight alone, a resistance band, or added weight, the gluteus maximus is required to generate its peak contractile force at the very top of the movement, in the position of greatest hip extension. This is critical, because it is precisely this extended, loaded position that habitual sitting robs from the glutes' experimental vocabulary. The hip flexors, shortened and overactive after years of chair-bound posture, pull the pelvis into an anterior tilt that keeps the gluteus maximus in a state of chronic elongation and underactivation. The hip thrust systematically counters this by demanding contraction in the range the muscle has forgotten, and it does so under conditions of mechanical tension that force the nervous system to recruit motor units it has been quietly neglecting. What happens over repeated sessions of this demand is a process called neural adaptation. In the early weeks of training, well before any significant change in muscle size becomes visible, the nervous system begins to change the way it manages the gluteal complex. Motor units that were previously recruited only partially, or only under extreme effort, begin to be called upon more readily and more completely. The threshold for activation lowers. The synchronization between units improves. The result is a measurable increase in strength and control that precedes any structural change in the muscle fiber itself, which means that even in the body after 50, where hypertrophy may develop more slowly, functional gains arrive with surprising speed if the exercise is performed with genuine attention to the quality of each contraction. This is why form, in the hip thrust, is not merely a safety consideration. It is the actual mechanism of the exercise's effectiveness. Squeezing the glutes deliberately at the top of each repetition, holding briefly in that fully extended position, lowering with control rather than collapse, these are not stylistic preferences but neurological instructions, signals sent with every repetition that tell the nervous system exactly which pathway to reinforce, which motor units to prioritize, and which pattern of recruitment to gradually make more automatic. The exercise, practiced this way, becomes less a physical act and more a conversation between the brain and a muscle it had, for too long, stopped listening. Speed is not the only currency of strength, and after 50, it is rarely the most valuable one. The body at this stage of life carries within it a quiet abundance of slow-twitch muscle fibers, type 1 fibers, built not for explosive bursts but for sustained, enduring effort, and these fibers respond to a very particular kind of demand, controlled, deliberate tension held across time. The standing resistance kickback speaks directly to this physiology. It does not ask the body to move fast or to lift heavy. It asks it to move with intention, to sustain a contraction through a full, unhurried arc, and in doing so, to re-engage a muscular system that has been waiting for exactly this kind of conversation. What makes this exercise distinct from many other glute-targeting movements is its postural dimension. Performed standing, it requires the body to balance on one leg while the other extends deliberately backward against resistance, and that balance demand is not incidental to the exercise, it is inseparable from its value. Proprioception, the body's internal sense of its own position and movement in space, declines measurably with age, and this decline is one of the most underappreciated contributors to instability and fall risk in adults over 50. Every repetition of the standing kickback trains not only the gluteus maximus but the entire postural feedback system, the ankle, the stabilizing hip, the core, and the brain's continuous recalibration of where the body is and how it is holding itself. The tempo here is the teacher. A slow, 2-second extension, a brief hold at the end of the range where the glute is most compressed, and an equally measured return. This rhythm is not a beginner's compromise but a sophisticated neurological instruction, a signal that asks the slow-twitch fibers to sustain rather than spike, to build endurance in the muscle tissue that will carry a person safely and confidently through the decades. The body that trains after 50 does so inside a hormonal environment that has fundamentally reorganized itself, and to ignore that reorganization is to misunderstand what the body now needs from effort. Testosterone, present in meaningful quantities in both men and women, plays a central role in the signaling cascade that follows muscular damage. It is part of the biochemical language that tells satellite cells to migrate towards stressed fibers, initiate repair, and lay down new contractile protein. After 50, its availability declines, not catastrophically, but measurably, and the downstream consequence is that the window between productive stimulus and excessive breakdown becomes narrower than it once was. This is not a reason to train less. It is a reason to train with greater precision, greater awareness, and a more sophisticated relationship with what the body is actually communicating during and after each session. Estrogen, which many people associate primarily with reproductive function, is in fact a profound protector of musculoskeletal tissue. It supports the integrity of tendons and ligaments, moderates inflammatory responses after exercise, and plays a role in regulating the satellite cell activity that drives muscle repair. In women navigating the years of perimenopause and beyond, its decline introduces a vulnerability in connective tissue that does not always announce itself with pain before it announces itself with injury. Understanding this shifts the philosophy of training away from the pursuit of maximum load and toward the cultivation of optimal load. Enough tension to stimulate adaptation, enough restraint to allow the tissue the time and conditions it requires to respond. Growth hormone, released primarily during deep sleep, is the body's primary overnight construction crew, and after 50, both its quantity and the duration of its release contract significantly. Sleep, then, is not a passive reward for effort but an active and irreplaceable component of the training process itself, the phase during which the stimulus delivered during the day is converted into the structural change that makes the next session more productive than the last, and the body more capable than it was the morning. There is a seduction in intensity, a cultural story, deeply embedded in the way we think about transformation, that tells us the bigger the effort, the more dramatic the change. But the body does not read cultural stories. It reads signals, and the most powerful signal a body over 50 can receive is not the signal of maximum exertion pushed to its outer edge, but the signal of reliable, progressive, patiently applied demand returning again and again across weeks and months with the kind of consistency that the nervous system and the muscular system alike begin to recognize as the new norm. It is this recognition, this biological expectation of recurring challenge, that unlocks the deeper mechanisms of adaptation, the ones that reshape not just a single fiber but the architecture of how the entire system organizes itself around movement. What consistency does, at the cellular level, is create a cumulative environment of anabolic signaling, a sustained chemical atmosphere in which the conditions for growth and repair are never fully allowed to lapse. A single session of hip thrusts or standing kickbacks sends a message. 2 sessions, reliably repeated across 6 weeks, begin to rewrite a pattern. 3 months of unbroken practice shifts what the body considers its baseline, its resting state of readiness, its default level of gluteal tone, postural stability, and neuromuscular coordination. This is the compound return that no single heroic effort, however impressive in the moment, can manufacture, because it is built not from peaks but from the accumulated weight of ordinary days when the work was done even when motivation was quiet and the result was not yet visible. 2 exercises, chosen wisely and performed with genuine attentiveness to what the body is experiencing in each repetition, carry within them everything necessary to begin this kind of transformation. Not a transformation of appearance alone, but of capacity, of confidence, of the quiet internal knowledge that the body is being tended to rather than surrendered to time. That each week is an investment accumulating interest in the only account that truly cannot be reopened once it has been allowed to fully